how I dealt with your grading your labs? Did you find your PowerPoints? Seems like sort of a strange way to go about it, but I like being able to have your grades and your maps together so you can compare and understand. I'm trying to be as transparent as possible about how I'm grading them too, so showing you the possible points for all of those features and then why you had deductions. If you have questions, feel free to ask them. Just send me an email, or if you need to set up a time to talk about it, if you need more explanation, that's fine. I'm just going to upload one more thing here so that we can go through some stuff hands-on at the end of this lecture. And see if I can get Melanie's up here on GChat. Okay. Some of the lab work together, and then I'm going to let you go and finish the chapters after on your own. And I'll post your assignment tonight. Good night. Okay. So, okay, so today we're going to focus on some of our capacity in GIS to query data. So we're going to start off by looking at sort of the format of databases in our GIS. So when we have a GIS system, we have a GIS and a database management system, and the abbreviation for that is DBMS. When we talk about GIS, you guys remember this definition of a computer-assisted system for the acquisition, storage, analysis, and display of geographic data. We've focused mostly on that display component so far. We've talked a little bit about how stuff is stored, but the DBMS side is really that storage and some of those analytical tools. So this DBMS underlies sort of the interface component of GIS that you're becoming more accustomed to working with. They're sometimes used independently, database management systems, for other sort of management and processing of huge databases. Really, it's more than just a database. It's the whole system of managing a database. So it's all of the components, the software that is designed to organize and manage all of these big data sets. So sometimes people get confused by the database versus database management system, and these are just some of the different things that are included in a database management system beyond the database. So there's a whole model of how the data is stored, a way to query it, different security measures. It's managed so that it's always being updated. It's managed so multiple people usually can use it, and there's a number of different tools and applications. So again, it's the system for how we're managing our data. I'm not sure what's happening. Okay. It's how it's stored, how it's organized, and how we query it. So this is just to sort of illustrate that difference between our GIS and where we have this database management system is in the background, the storage, indexing, security, querying, all of the backup component of our data goes through our database management system. And then when we're working in our GIS, we're mostly doing these other components, the displaying, the mapping, the analysis. There's different classes of database management systems. There are different models, depending upon how the data is being stored. There's a lot more information that you guys will probably remember or ever refer back to, but just so that you understand that there are these different models for how data is stored. If it's stored just in simple rows of text, if it's a flat model, if it's a hierarchical or relational model where you've got tables that are all relating to each other in different ways, or if it's an object-oriented model. And in GIS, mostly they're object-oriented models. So you have like an object, and then all of your tables are going to be referring to that singular object. Just some differences in the way that these models are structured. In a hierarchical and a relational model, the data is stored in multiple tables, but it depends upon how those tables are relating to one another. So in a hierarchical model, it's more like a parent-child relationship. You've got one database on the top, and then they all refer down to finer and finer details. Versus a relational where you're using keys to go between multiple tables. So like in GIS where we have those object IDs and we're using that to relate one table to another, that's a relational model. So most common in GIS are these relational models. Just some more details how those kind of look on paper. If you were to see a flat file, you see there's all of your data is stored in one file. Everything's included here. Versus a hierarchical where you've got this is the parent, and then you have all of these child tables, these tables below the parent, because the parent should always be on top of everything. Sorry. And this is a different example of a relational where you have different relationships in your tables, how you can query it. You're going in between all of your different tables based upon those ID numbers that relate from one table to another. Okay. So in GIS, as we said, they're relational are the most common. Those where you have ID numbers that we're using to query between different tables, different attributes. And typically we're using that object-oriented table as well, where you have a file that's going to store your spatial information and your attributes. And then you can have other relational tables that are going to go back to that object ID value and are going to relate different components, different attributes to that object that you have identified. The idea is that it's less complicated than a geo-relational table, and it's easier to do queries in it. Okay, so whenever we're using GIS and we're focusing on this database management system, really we're thinking about how we're storing our data, how we're retrieving it, and how we're backing it up. But when we're working with more of our editing and our mapping components, again, we're really in that GIS side of it, where we're doing more of our kind of visual analysis versus the storage of the data. You guys are familiar now with what some of these attribute tables look like, how things are stored. So it's a little bit of review here, where you have records, different fields for your attributes. Typically, when you're working with these tables, you're defining what those fields are going to be before you start working with your data entry. There are different types of tables that we use. They're either attribute tables that are connecting to your spatial data, or they're standalone tables, which you don't have to have spatial data included in those standalone tables. What you have here instead are these object identification numbers. So that's how they're relational back to your spatial data. So this is like whenever you're importing Excel tables or something like that. Those are going to be standalone tables, but you need to have this attribute, the object ID number, in order to connect them. Sorry, guys. Let me turn that off. Okay. Always something. So another, just some examples again of things you've already seen, how those tables, what those tables look like. Where you have, and this one is one of those, a spatial table. It's got the information associated with it versus the standalone tables, which it's not going to have any of the necessarily spatial or objects, the shape information. Or you can also have them combined together, where you have here the shape information, then you also have all of those attributes. So you have the capacity in GIS to take those tables and to combine them together. You know that now, right? It's kind of familiar. And the reason why we're talking about that is because it's the power and the structure of those tables that allows you to do all of the querying, which is a great tool that you have in GIS. You don't have to just look at a map and say, oh, isn't it pretty? You can do all types of analysis to try to understand more about whatever it is that you're looking at. So queries are the most common operation in your database management system. It's what you're using it for. And what we're doing in a query is we're just trying to select a subset of the data. We have a question we need to answer based upon the attributes we have stored. And so we're trying to select a particular subset. They can be really simple, like all of the green polygons or something like that, or they can be really complex. You can combine multiple queries together and make it more complicated. So the objective, again, is just to try to take that massive amount of data that you have stored and to try to ask a question to identify a subset, a different group. So an example here is if you had our U.S. map, you knew the population of every state, and you just wanted to know how many states have more than 1 million people, you could query that in your through your database management system and get your result. So it pops up with the answer. It can either be just in a tabular format, or it's going to show you on the map. Typically what you do is you ask those questions and then you create new data layers from those questions. You guys hear that weird feedback? Is that me? Am I mouth breathing? I don't know. There's a little bit of feedback, Jeff. I don't think it's that big of a deal, but it sounds like someone's breathing into the microphone. Maybe if I move my microphone. Huh? Okay. So what that looks like after you do that query, it's going to highlight those features in your attribute table. It's going to highlight those features in your map. There you go. Look, those are the states that have a population over 1 million. Very exciting. Would you have guessed that? This is Michigan, right? That's Illinois. Thank you. Chicago. Okay, now it's worse, Jeff. Okay, so there's two types of queries. There's either attribute queries, which we were just looking at, where you're just asking a question about the data based upon the tabular data. Or there's spatial queries, where you're asking some sort of a spatial question about it, like what's close to another object. Obviously, for a spatial query, you need a spatial layer. So just some more examples of how we go about using our attribute queries. Here we have it's a vegetation layer. It's really hard to see the screen this way. Oh boy. And that was the lecture. So if you want to select some features, we're curious about where, say, the aspen stands are growing in a vegetation map. So we can query through our attribute table, just stand over here, what if that class was, the aspen cover class was, say, TAA is that class. It's going to pop up and show us all of those all of those features in our map. If we wanted to know, we can add multiple queries together. So we wanted to know about mature trees with open crowns. If those were components that we had in our data we had in our attribute table, we can query that. So you can see how it's helpful. I don't know what's causing it to. Okay. So spatial queries, whenever we want to explore the spatial relationship between objects. So here we're looking at rivers. So we have two layers. We have our rivers layer and we have a counties layer, and we want to know about how the rivers are intersecting the counties. So we can query our counties layer here and look at wherever a river is intersecting one. And it's going to both highlight that in our map and it's going to highlight it in our attribute table. I don't hear it anymore. Okay. Okay. And then if we want to, we can actually go and combine both our spatial queries and our attribute queries together, which gives us the capacity to ask more complicated questions. So we can know more about what the attributes of a particular location are, and then different spatial questions about it. So this is just showing a map that's trying to identify where earthquake-prone cities would be, and which ones of those cities have large populations. So the spatial query would be identify all cities within a certain radius where there have been earthquakes, and then within that we're asking it to query our attributes, so which of those cities have populations of a certain size. Okay. So attribute queries are formulated using our attribute table and using a basic querying language, SQL. You guys have probably heard of SQL before. It's a very basic way that we can ask questions of our data, and there's some sort of common operator terms that we use in SQL. Inside of ArcGIS, it actually gives us a whole interface tool that we use to create those query expressions. So we don't actually have to know all of the SQL language. It actually will formulate the expressions for us. This is just showing you that the question before, so how we're going to select populations greater than or equal to 500,000. Pretty basic. If we wanted to select from within that, we can also use like I'm not sure what the beef cow expression is here, so I'm going to skip that one. But we can use less than two different attributes in our table as well. Just one point is that in most databases, when you're using SQL, expressions are case sensitive. So depending upon how the data is input into your database table, you have to maintain those cases. So the operators that we use, relational operators should be pretty common, less than, greater than, equal to, and then there's a whole set of Boolean operators. The most common ones we're going to go through those are the and, or not. And with those Boolean operators, we're evaluating different pairs of conditions. One thing to always keep in mind is that when we're using the and feature, we're being more selective. We're making sure that the features we're looking for are meeting both conditions. If we're using or, it's more relaxed. We're saying we want it to meet at least one of those conditions. So what does that look like? This is showing that you have A and B, so where you're having both of those conditions are being met here, so it's a much smaller sample, versus A or B, it's everything, both A and B together, more inclusive. There's also some operators that can have this X or X and A not B, so you can have it's A or B, but not what's included, what's shared, what's combined between them, or you can have what is A but does not include B. So those are just different types of operators. The database that you're using will determine whether or not you can query it that way. So again, A is more restrictive, or is more inclusive. So not is like the negative, the opposite of sorry, having a hard time understanding that. Substituting equals for not, then selecting all other records. So it's like A, not B, which we just looked at. Order of the operations for how you're querying your data is important. So if you're going through a multi-step process, how you're doing it matters. It's going to impact your results. Okay, so this is just showing another example of how we're querying our data. If we wanted to select all of the students from New York State, we have our whole universe of data here. So T is all of our students in a university. A is our students from New York. B is geography majors. C is English majors. So if we're going to select students who are from the home state of New York or the home state of New Jersey, we're going to be including everybody who's, I guess everybody in here because we don't know who's from New Jersey, but how we read it, we're going to go first to home state of New York, so it's going to select all of A, and if we're using an OR operator, we're going to expand our selection. We can include more than just those. So you can use multiple conditions to try to kind of hone in on your selection even more. This is just showing a set of properties, residential and commercial properties, and their value. So the land use is these two different ones, residential and commercial. So if you wanted to know here if the land use equals residential or the land use is commercial, and you have a value of greater than a certain point, it's going to select everything in the whole universe of residential and commercial, and then those values. Or if you were going to say the land use equals residential, would include all of the residential, but then if you only wanted commercial properties that had a certain value, depending upon how you bracket that expression, it's going to select it differently. You guys all with me? So this is just showing how those two different, how that selects properties differently based upon those brackets. So in this one, it's selecting everything in both universes with a value greater than 100,000, right? And in this one, you're selecting all of the residential and then only the commercial based upon it meeting that higher value. Okay, not that complicated. It's just a matter of making sure that you know what steps you're going through and you think about your expression, the structure of your expression and what the outcome is going to be. I think one of that and or thing sometimes will catch you too, because you may be thinking of it backwards, because you may be thinking, I frequently have to remember that and is more restrictive than or. Okay, so the other way that we query our data is through spatial queries. With spatial queries, there are sort of three major types of spatial operations that we use. Intersections, so how does one feature cross another feature? So are there roads crossing an aspen stand? Are two polygons sharing a border? Containment operators, so it's something within another thing. And proximity, so how close is something to another? There's a whole group of operators within each one of these types. So within intersect, there are going to be different types of intersection. Within containment, there are going to be different types of containment, and within proximity, we can do different types of proximity operators. So those are just sort of the parent types there. Whenever we have a spatial query, we have two layers that we're working with at the same time. The target layer is the one that has the feature that we want to select, and the source layer is what we're comparing those target features to. So if our question is, we want to select the roads that are intersecting the Aspen stands, the roads are the target layer because that's what we want to be selecting, and the source is the Aspen layer. The inverse of that is shown here. So here our roads are being selected. If we wanted to know which are the Aspen stands that are being intersected by roads, then we go about that query the opposite way, where the Aspen stands are our target layer and the roads are our source layer. So for our intersect operators, features are going to be included as intersecting when any part of one feature is going to cross another part of that feature. The way that we can kind of limit that query are with these separate types of spatial query operations we have down here, which are going to give you a smaller sample. So intersect is going to give you anything that's going to cross a polygon in any way, but if you want it to be much smaller and you want it to say only share a particular line segment, you can use these different operations. Sometimes you have to play around with your operators to get it to choose exactly what you want. Again, here is showing that big containment operator. Any feature that's going to enclose all of another feature is going to be included with contain. And then there are all of these different options. Proximity. You'll use proximity operators a lot. So it's going to tell you whether or not a target feature is within a specified distance of your source feature. So you get to define what that distance is. So here we're just looking at volcanoes within 100 kilometers of an interstate. Just an example of what a proximity operator would look like. Okay, so you can see that you can query data in a huge number of ways. You can create multiple steps in your query so you can get more finely detailed. Okay, so one thing that comes up when you're working with querying data is that if there are any problems in your data layers, or if there's any alignment issue in your data layers, it's going to impact how your data is going to be queried. So you always need to make sure that there aren't sort of inconsistencies that are giving you false information. So an example here would be that your road, actually the city's supposed to be on the road instead of off of the road. Or here, if you were doing any sort of a containment or an intersection operator, you would get a false result because these two boundaries are supposed to be lining up. Okay. Okay, so the other thing that we can do with our tables, with our attribute tables, are calculate a whole host of different field statistics from them. When you're working inside of your attribute table, you have the ability to just right-click on a field and calculate all of these different values. It's showing you just sort of the basic statistics of each one of those fields. So this is showing you what those are: the counts, the min, max, sums, standard deviations. You can go and look at different fields within that box, but it's only going to give you one field at a time. You can also use summaries of the table. So if you needed to know information from more fields or more features, you could do a table summary. And it's going to give you another table that's going to give you information, whatever type of data you're trying to query. So this is just an example of some of those summary tables. If you wanted to know how many earthquakes were in each state, you were summarizing everything within California. It's going to show you all of these different variables here that are in your attributes. You also have a field calculator. So this is showing you an image of both Idrizi here and in ArcGIS. So frequently you'll need to ask more complicated questions about your data than just what's the sum or what's the mean or min value of your field. So if you wanted to do something, if you needed to know something more than just those values, you can use a field calculator, which gives you essentially like a whole calculator that you can create your own queries of your data with. You can use basic mathematical operations in it. And you can also use SQL expressions if you needed to. If you were doing sort of an attribute query, you could identify things and then do assess the values within that attribute query. Like you do in Excel. I don't know if you can do conditional stuff. You can do like logical. Is that a logical operator? If then? I'll answer that later, more detail. So in summary, what we've gone through are looking at what's the structure of GIS that gives us the ability to do all of these different queries, and those are the database management systems. We looked at some tables, and we talked about the different types of queries that we can do, as well as some of the other tools we have to look at the statistics in our data. Okay, so in ArcMap, what that looks like, we're just going to go through this quickly, and then I'll have you guys play around with it with me with some real data. Whenever you're inside of your table, like I was saying, whenever you right-click within your field, you're given all of these different tools. So here's where you have that summarize option, your field calculator option, and down here in the options button, it gives you some other different components. Select by attributes, adding your field, which you guys have done right with that editing example. Joins and relates, which you understand now, and then exporting your data as well. The other place where you can get to those different querying options is under your selection tool, and it gives you two options: select by attributes or select by location. So you're always thinking about how you're going about selecting your data. Whenever you are selecting by location, remember you've got your two different layers, your target layer, and that's the one that you're going to be selecting the data from, and your source layer, so that's the one you're looking at the relationship with it. And it's going to give you, this is the drop-down menu that's going to give you all of those different types of spatial relationships that you would be asking it about. You can also do select by attributes from that same drop-down menu. Or you can do it, again, within the table, within that options button at the bottom, which got cut off there. Whenever you're selecting things by attributes, it's going to open up this dialog box. It's going to give you all of the options for how you can create your query expressions. So the other thing is that once you go through and you have created your query and you've queried the data, it's going to show you that information in two different ways. Both in your map form, everything's going to be selected, and in your table, all of your features are also going to be selected here. It shows you how many of your records are being selected, and you have an option too to go back. I'll show you to toggle so you can see only those things that are selected versus everything. And here's where we're looking at how we can calculate different field values within our attribute table. How we can right-click on our fields to get to that summarize dialog box. Gives us a huge selection of I might want to summarize our data there. Okay, great. Okay, so that's the boring overview. And then on Sakai, if you guys go under lab, I shouldn't say boring overview, right? It was riveting. Under this lab 4Z is a zip file of some of the files that we're going to work with. And if you download it. Does everybody, who's having a hard time, Michael, you're having a hard time unzipping stuff? Did you figure that out?
Yeah, WinZip is like,
Okay, well you can, if you can't open the files, you can follow. I can't see my screen here. Let me see how I did it. I don't know if I have any. I may not have anything on here. I have a disk. Okay. Okay, and launch ArcGIS. Turn on your computer. How's everybody doing? Is it working? Sorry, Jeff, I'm going to close this because I can't see the screen. There, that's better. Okay. So, in your folder, we have a whole bunch of different shape files, right? Cabbagetown is there, and then there's a second subfolder called spatial data. Okay. So, I think that was 13. Look at how much you guys have learned, right? You can open ArcGIS and get right to what you want to do. Are you feeling like you're more confident in navigating now? Somewhat? Everybody survived the projections lab, right? Some of you more easily than others, but that's normal. Okay. So this is a neighborhood in Toronto called Cabbagetown because apparently they used to grow a lot of cabbages in their front yards. The immigrant population that originally settled there, so it maintains the name Cabbagetown. So if you put Cabbagetown on top, you can see how these are zip codes, how they're maintained, how they lie on top of the rest of the city. So there's lots of different ways that you guys know of just doing basic queries of your data. So if you use that identify button, you can see, maybe you can see what more information about those features through this little dialog box. So it's going to show us what the postal code is, because that's pretty much what this layer is. You can know more about what data is available by looking specifically in your attribute table. Here you can see that Toronto background doesn't really have much except for just the postal code. and the location and some information about income. The Cabbage Town has a lot more data in it. How the population is distributed and these other attributes, household income, distance to grocery stores, and such. And then we have a street layer here as well. So another thing that you can do when you're wanting to get more information about your data, just to do basic queries of it, is in this identify feature. If you go through, you notice that when you click on different polygons, you're only allowed to look at one at a time. It gets lost because it disappears and goes to the next one. If you use this other feature called an HTML pop-up box, what it does is it shows you all of those features, all of the features of your polygon in a much more succinct way, sort of. And then when you click on another one, it's going to give you that same summary table for a different area. So that can be really nice if you're trying to compare, you want to compare features, compare something between different areas, so you can see that, what's the average household income in these different zip codes. But that's not a very powerful tool if you wanted to, say, select a whole subset of your data. So you needed to select all of the postal codes that had a certain household income. If you went through and did it like this, you'd be spending a long time and very inefficient. So if we turn off this guy, we can go to that select by attribute option here. So when you open that, it's going to have you choose which layer you're interested in selecting your features from. So here we're looking at Cabbage Town. Gives you the dialog of, do you want to create a new selection, or if you had something already selected, you can add to that, or you can remove it, or you can select only from a subset. So that's how you can start to think about doing multiple queries together. So if we were only interested in, say, average household income from the Cabbage Town layer of a certain value, or I guess it makes more sense to be higher than, greater than, or equal to a certain value. See, these are all of your SQL operators right here. If you hit this Get Unique Values option, it's going to fill in from your attribute table what all of the values of average household income are. And you can scroll down and see, wow, it's a huge number. And since here we're kind of thinking more generally, we're not interested in what that specific number is or higher. Say we want it more than 50,000. You can just type the number 50,000 in. If you hit OK, it instantly queries your data. You can see that all of those postal codes are highlighted. If you go and you look at your attribute table now, you can see that all of the records in here are highlighted as well. You get the count. You have 34 total that have been selected. If you only want to look at those records, if you hit this button, it's only going to show you those. You guys with me? Okay. If you want to get back out of that, just go back to the Show All Records feature, and it'll go and I'll show you all of the records in the data layer. You guys remember that whenever you like the data that you've selected, or if you need to work with it more, if you go and you export your data, I'm not looking in the right folder here. You can save it as, say, household income 50,000. Okay. And then you've created a new map layer that you can work with. Okay. So you can get to that attribute query also if you were in your table. Option. select by attributes comes up here, and it'll take you back to that same dialog box. As I mentioned, you can add to your current selection. So if you wanted everything with a household income of $50,000 or greater, and say you were interested in how far they were from grocery stores that were within, how about greater than, let's see what our values are, say greater than 1 mile. If you wanted to select a value from here, you just, oh wait, that's a tenth of a mile. You just click on those and you hit apply. It's going to tell you that that wasn't a good query because nobody in that income bracket is that far away from a grocery store. You guys know the concept of, have you heard food deserts? Mostly it's people in lower income areas that don't have access to food, to grocery stores. What about there? Okay, so then from within that, it's selecting, I guess I didn't have that other one selected, so it's selecting all of the postal codes that are greater than 3, I guess that's true, 0.03, I think we're in miles. Right? Doesn't have our units here. And we can see all of the different postal codes that have been selected, and we can see that it's the majority of them on our map. Okay. So again, other things that we can do just by doing sort of attribute queries, if we go through and we want to clear our selection, you go to this option here. You have the same box up here if you wanted to clear it from the map. If you were curious about what the average household income was, some of the properties there, if you go to that summarize box, if you go to the statistics box first, that gives you what the sort of the standard set of statistics for that. So it shows you your min, your max, the sum of all of those values, the mean. Obviously, it's a pretty wealthy area if the mean's that high, huh? And then it's showing you the histogram of the distribution of the data. If you wanted to do more complicated summaries of that data, it's going to give you the option through this dialog box of all of your different your field values here. And then if you wanted to do different analysis of it, if you wanted your average household income, if you wanted the standard deviation, it's going to give you an output table, which you can change if you want it to be a text file, if you're going to be exporting it, or a PDF. Okay. So pretty straightforward, right? Okay. So the other way that we can select our data is by location. So remember, whenever you're doing a query by location, you're going to have you have to choose your target layer. So say I want to choose from our higher household income layer, and I want to know which of those are going to be intersected by one of, well, that's kind of silly because of course they're all going to be intersected. How about which of them are going to have an identical boundary as our source layer? So which one of these are they all going to have identical boundaries with our streets? And we hit OK. And for some reason it's not a valid relationship. That might be because of some sort of topology error. So let's do a different query here. So say that we're just going to do a basic intersect. Hit OK. So now it's going through and reading everything, and it's showing me again that it's selected kind of like I thought, almost all of them. I guess one of them doesn't, or some of them don't intersect with the street. That's surprising. I would say that that's definitely, what do you guys think? Is this a spatial shift error here? What do you think about those streets? Does that look right? Isn't that sort of funny because this is from the ArcGIS book and the data doesn't align, right?
What would be that difference? Like if you were physically there mapping it out.
This is a project. You mean what's the distance or what? This looks like, if I were to look at that, I would say, oh, that's a projection problem.
Well, no, I understand that. I mean, because we're like good data were using a small portion of
Yep, Cabbagetown's a neighborhood inside of Toronto.
right. So what would that?
What would this, you mean on the ground, if this actually was the difference? What's the distance? Have you guys seen this tool? Okay, this is a good tool to know. Here, I'm just going to measure the distance between my two lines. You can the option. Well, our units are a problem here. We're working in degrees, but you have the option of saying, okay, I need to work in miles because I don't understand anything, and it's showing me what that distance is. So. You can ask any question you want, and we can answer it for you in GIS. So again, under here, you can change your units depending upon what your maybe inches would be better. So it's not a big shift, but it's definitely not. And you can see how those layers overlap is going to be really important for how your spatial queries are going to look. Can I fix it? Isn't that a good question? Yeah, you could try to fix the projection to see if you get it to align. The other thing that you could do, do that here.
Well, they're not everything. You know, layers is off of that.
Let's zoom in and see. I can only look where I can see things overlaying. There's different, looks like different problems. It could also be that the postal codes, well, they should follow the road line. If you wanted to be sure that you could do an analysis with your streets and the relationship to the postal codes, you could also buffer those streets and make them a bigger feature so that anything it was going to touch would, because right now our street is obviously represented as a single very thin line when in actuality streets are going to be wider than that. So you could buffer it and make it a bigger feature. Or you could also do in your select by location, you could say that you wanted it to be within, you want it to be a distance operator. Let's see, so where's our distance operator? Maybe it's not going to let me do it with a feature. Or within a distance. Okay, so say we would just increase this distance. I don't know what this is going to look like, if it's going to work or not. Oh, of course I don't have it highlighted. Let's zoom out and see if it works. There, so that solves it. So instead of doing straight intersect, doing the distance from it and making that distance something that was wider than that actual line, it solved that problem. So I guess one lesson there is that there's always about 100 different ways to get to your answer. So sometimes if the first way you're thinking about querying your data doesn't work, you can think about doing it in a different way. So I also gave you guys a different set of data that we can look at. So just to show you guys too that whenever you're looking at adding data, you can always go over here. I think I need to connect to a different folder. And you can see more clearly all of the data that you have on hand. If you're looking at it through your ARC catalog, it's going to show you all of the data layers that are available. Just have to go and connect here. And then once I open it under catalog, I can see all of the different layers. So I can see that I've got some polygon shape files, some cities. I've got an image. And then if you drag stuff over from catalog, it displays it for you. So that can be nice when you're trying, especially when you're trying to get oriented to what data you have to work with, instead of having to go and keep adding all of those shape files. You can see it all there organized. So here this is an area in California called Guerneville. Is it a silent E? I don't know. Where you've got this, the Russian River goes right through. It's in I guess Napa Valley. They've got it rough there. So here you can see this is the Russian River. This is identifying that floodplain of the Russian River, and this is the parcels within the town. So obviously, if you are, say, an insurance agent, you want to know what are those parcels that are within the floodplain. Or if you're a city manager and you know that there's going to be some sort of flood. So you want to go through and you want to select from these parcels. So we're going to isolate what those parcels are. So that's our target layer. Anything that is going to be within our floodplain. So we want it to, it's going to be what kind of operator do you think we want to use here? Remember, there's the groups are intersect, contain, or a proximity. What do you think we should use? Containment? Yeah, that would definitely work. So if we say, let's look at all the target layers that are contained within that source layer. That's a good point. So if you wanted to make sure that they weren't completely contained within. Well, what's up with that? That didn't seem to select anything, did it? Let's try that one again. So anything that's in this Guerneville pulse, the target layer features contain source layer features. Yep, that was backwards. You guys see why? Because my source layer is so much bigger than the features in my polygon, so I need to actually have that opposite, right? Target features contain source layer is what I said, and what I really need is target layer features are within the source layer feature. So it's the opposite. There we go. But Andrew's point is right. Say, but what's up? Why are we not getting like this one? That's definitely inside of the floodplain, right? You always have to evaluate your analysis there. Okay, so, and these guys, these aren't within it. Is that again just because it's not going to be completely contained? Let's zoom in here. Yeah, see, so part of these polygons is outside. It's going to be outside of that floodplain. So we need to go back and think about that. Let's try and, you guys all work with transparencies. I forget all the things you know and don't know yet. So if I wanted to see more of that relationship between my two layers, if I make the top one transparent, I can see through it to see what's going on underneath it. And then I can understand that this is a problem of it not being completely contained within. So that containment operator is quite literal. Target features are within the source layer features. So perhaps we need We don't want it to be identical to the source layer features. Target features touch the boundary of the source layer features. Target features share a line segment. Now we're getting into the intersection operators, aren't we? Crossed by the outline. I mean crossed by any part of it, right? So that would just be crossed. Let's see about, let's try touch the boundary, I think. So, no, that definitely wasn't the answer, huh? Am I driving home the message that you really oftentimes have to play with a lot of these different spatial relationships to get it to come out to what you want? Okay, so let's say they are within a distance. Contain, completely contain. We didn't do intersect. Let's do intersect and see what that one looks like. Well, that's giving us the opposite problem, isn't it? Let's see. Maybe let me take this off and see. It's giving us a slightly larger sample than we probably want. Let's look at here though and see if maybe it's not. Maybe that does intersect it. What's that? Yeah, we can reduce our sample. But now when you actually look up here, this is the area that looked like it was a little bit was selecting too many, but what you can see is that it's actually crossing it. So if you were, say, especially if you were an insurance agent, that's still going to count as being within the floodplain. So it's probably more accurate to do that one. Okay. So remember, guys, that if we go back down here, if we wanted to say only focus on residential areas, say we weren't worried about commercial areas, maybe there's a flood that's going to happen at night and we need to make sure that anybody who's potentially going to be home knows that it's going to happen. If you want to go in and select from within that, you can go and you can do another, you can select, you can add to your current selection. So all of this is selected, except I don't want to be in the Russian River layer. I want to be in the parcels layer. And if I add to my selection, I think space zoning, if I get my unique values, this is showing me what all of the zoning of all of these parcels is. So if I was particularly interested in residential areas that are within that floodplain, and I hit OK, I would see, oh wow, it's like all of them. Actually, no, that didn't do it right. Because it did a new, okay. Let's do that again. Because it just selected even more, didn't it? Okay. Try that one again. Okay. Let's clear this. Okay. So if we let's just make a new layer from that, and we'll call it floodplain parcels. I'm going to add it on, and then we can select from the attributes within it. If you have to double click on this guy to add it to your statement, your SQL statement there, residential, hit OK. And then it does look like they're all residential, huh? Look at our attribute table. Okay, you can't tell because those highlights are so bright. So it's 11,032 out of 14,053. So you can do this, get them all highlighted. So one way to look at data too, sometimes it's helpful instead of looking at what you have selected here is to look at the inverse of your data. So here, there's this tool, switch selection. Did you see that? The nice thing about ARC is that everything, when you hover over it, it should come up with a, it should tell you what it is. There's select by attribute. Here, switch selection. So here, instead of having all of my residential properties highlighted, I'm going to do the opposite, and I'm going to look at all of the non-residential properties. Oh, you know what's wrong? Is that it's still, turn that off. There. So now all of my non-residential properties are highlighted in this layer. Okay. So if I go back and I switch my selection again, it'll show me the opposite. Okay, so those are just the basics of both spatial queries and attribute queries. You guys have any questions? No? Okay. Well, we're so much faster than I always think we're going to be. So what I think we are going to do now, I think the book is really basic on these, but there's 2 chapters, one on attribute queries, which is chapter number 12, and then chapter number 13, which is location queries. And then after that, I want you guys to go to chapter 18 to creating reports. 12, 13, and 18, yeah. Because what we're going to do is we're going to do some different queries of the data that we already have worked with, our North Carolina rivers data, the stuff you did for lab this week. We're going to do different queries and create some reports from it for our assignment. Okay, so if you guys want to start working on that, it's a 12:10, and then once you're through with at least those 2 chapters, then you guys can go, and I'll post your lab later.